you ever wondered why your phone gets warm when you're charging it for too long? Or why your bicycle's brakes feel hot after suddenly stopping? Or why does a plant use sunlight to make food? Now, firstly, when you look at all of these scenarios, they look like three individual scenarios. Now, what if I tell you that there is something which is common amongst all these three? And it's the fact that energy is involved and something happens to energy during all of these cases. So, first up, let us understand what is energy and then move ahead. Now, energy is basically the ability to make things happen or to do work. So, when you lift your school bag, or let's say when the bulb glows, or when the pressure cooker whistles, or when the fan spins, something is supplying energy. And that's why it is able to do the things it does. But here's one of the most important ideas in science: energy can neither be created nor destroyed, it can only be converted from one form to another. So, every phenomenon that you see in your life, right from switching off the light to the pressure cooker whistles, it's all just energy changing its forms. Now, of course, there are different types of energy, but the one we're interested in is heat energy. So, what is heat? Now, of course, when you think of heat, you think of keeping warm or feeling warm, right? But it isn't just a feeling. You see, when temperature of an object increases, right? So let's say there's an object and the temperature of that is increasing. It means that the particles that the object is made of, right? They start to vibrate or move in their position. And when these vibrations increase, they pass on the vibrations, right? Or the vibrations get transferred from one part to another. And the measure of energy with which these molecules or these particles vibrate within the system is what we understand as heat. Now, simply put, when particles move faster, things are heating up. But when they move slower, it means that it's cooling down. And heat energy is used in our day to day life. It helps us cook our food, it helps our engines run, and also keeps our body warm. And it also helps our body stay alive because our cells produce heat too. Now, where does this heat come from? Now, heat, of course, comes from different sources. It can come from burning fuels like LPG, wood, coal, or kerosene. It can come from rubbing our palms. It can come from the sun. And heat is even produced inside our body, like we discussed. And it can also come from mixing chemicals. But amongst all of this, there's one common idea that heat appears when another form of energy changes into heat. What do I mean by this? Let's have a look. So let's start with something simple, and I want you to try this out with me. Let's rub our palms really fast, right? Now, what do you notice? As you keep rubbing your palms faster, they start to feel warmer. So, what exactly happens here? When you're moving your hands, right? That's actually mechanical energy. But when you move your hands against each other, your skin resists that motion. Now, that is friction. So, effectively, what happens? This friction converts mechanical energy into heat energy. And this is the exact idea behind why cycle brakes heat up, why a car tire becomes warm after driving, why a hammer head heats up when you hit a nail repeatedly. It's all because of the fact that friction is converting mechanical energy into heat energy. Now let's look at another idea. Here let's talk about our phones, right? Our phones or our laptops. When we use them for a long period of time, they start to heat up. So why does this happen? Now inside the phone you will find many tiny circuits, right, through which the electricity flows. And these tiny circuits resist the flow of electricity a little. And eventually, what happens? It's this resistance that converts electrical energy into heat energy. So, if you look at electrical irons, geysers, room heaters, they all simply convert electrical energy into heat in a controlled manner. But now, of course, you see that heat is not just produced when we overuse our phones or our electrical devices. Heat is also produced at our stove. I mean, if you want to cook, you go to the gas stove, you take a lighter, and then you light up the stove. But how exactly does the stove burn? You see, your gas stove has a connection to LPG, right? And inside of this LPG is where the chemical energy is stored. And it's stored inside of the fuel that you find inside of this. So when you turn your stove on, you see that all this chemical rushes here. And then when you provide a heat source to it, we see that chemical energy gets converted to heat energy. It's the same idea behind burning a firecracker, burning wood, or even car engines. So when something burns, it's chemical energy being converted into heat. Now, yet another example that I can give you is that of the solar water heater. Now, you see, solar water heaters are normally installed in the rooftop of houses, and what they do is they harness energy from the sun and then they convert it into heat energy. You see, when sunlight hits the solar water heater, the panels here absorb the solar energy and then it converts it into heat energy. During the day, the ground becomes very warm, or why dark clothes feel hotter in the sun, because solar energy gets absorbed and there's conversion of solar energy into heat energy. Now, heat isn't always the end product. Heat can transform too. In thermal power plants, heat boils water, which results in the formation of steam. And this steam spins the turbines, as a result of which electricity is produced. So, from this, if you look at it, heat energy is converted into mechanical energy, which is then converted into electrical energy. So, different forms of energy keep converting into heat energy, and heat energy can convert right back into other forms. And with this, I hope that the different conversions of energy into heat is now clear to you.